Okay, this is Mr. Smith here. We are in section 4.9, graphing and solving quadratic inequalities. So when we talk about quadratic inequalities, first of all, we need to think about the idea that we're going to be graphing these things. Okay, so how do we graph quadratic equations? We can use an XY table exclusively. We can try to find a vertex by using negative b over 2a, finding the axis of symmetry, plugging that back in, and then finding a vertex and then getting another point or two. Or we can rely on the graphing calculator. All of those methods are at your disposal. Okay, so we have to be able to graph. But now we're going to talk about inequalities, right? So inequalities. Inequalities refer to greater than or equal to, less than or equal to. And so we need to consider shading. Do I shade above or below? We need to consider, is the line dashed or solid? Okay, those are the two extra considerations we have when we talk about inequalities. Okay. And so here are some graphs of possible quadratic inequalities. Remember that a quadratic function is graphed as a parabola. So we're going to be either shading inside the parabola or outside, depending on the inequality. Okay. Obviously, here are less than, greater than signs. And remember that a solution to an inequality is just an ordered pair, and that's what the shaded section represents here. Right? Every point in the shaded region would be a solution to the given inequality. Okay. So our process is similar to the process that we use for all other inequalities from now until you're done with math. That is, number one, we graph the equation. Okay, so we graph the equation. Number two, we pick a test point so that we can determine whether we shade inside or outside. Okay, so we pick a test point to shade inside or outside. And lastly, we shade the region. Okay, we shade the region. Okay, again, we have to determine whether it's the line should be solid or dashed. So we graph the equation. We decide if it's solid or dashed. We pick a test point, and then if that test point is a solution, we shade that area. If that test point doesn't work, we shade the other area. Okay. So here we go. Y is less than or equal to negative x squared plus 2x plus 3. Okay. Okay, so step one, we graph the equation y equals negative x squared plus 2x plus 3. And the way that I'm going to start this is by finding the axis of symmetry. So axis of symmetry, AOS, x equals negative b over 2a, which is negative 2 over negative 2. So the axis of symmetry is just 1. Okay, so that tells us our quadratic's going to go along this guy. If I want to find the vertex, I just plug 1 in, and I get, let's see, this will be negative 1, plus 2 is 1, plus 3 is 4. So it should be 1, 4. Okay, so there's that point. So I know that's the vertex of my quadratic, and now I can use an XY table to get a couple more points. Again, I'll use the fact that we have a symmetry. Right, we have symmetry here, so I don't need to do anything too fancy. But maybe we pick the point, or the x value of 3. X value of 3 and see what we get. So here, if I plug in 3, I get negative 9. 3 squared is 9, but then it's negative. This is 6. This is 3. So this is 9 minus 9 is 0. So it gives us 3, 0, 1, 2, 3, 0. And then, of course, we can use our symmetry and come out here. Okay. And so I'm about ready to draw the quadratic. I'm about ready to draw the parabola. The first question I want to ask then is, do I draw it dashed or solid? And so I look here and I see that I have the line underneath, so it should be solid. Okay, so there's our parabola. And then the next question we want to ask is do I shade inside the parabola or outside the parabola? And so I know I'm should shade underneath, but it's a little bit hard to see what underneath means here. And so it's always advisable to just pick a test point. And so in this case, 0, 0 is the nicest test point you can always pick, as long as it's not close, right? You don't want to have 0, 0 and not be able to tell if it's inside or outside. Okay, so 0, 0. So I get 0 is less than or equal to 3. That's true. So that means I shade underneath the parabola. And again, that shaded region represents the solution set for the quadratic. That means the quadratic inequality. It means every point there is the solution to this original inequality. Okay? Let's look at it again. This time, since there isn't a middle term, I can use my knowledge of how transformations work. We have a knowledge of transformations. And so this basically is just the graph of x squared, and it's shifted down 2 units. Shifted down 2 units. So here we go. And for my sake, that's good enough. I mean, you can try to make it a little bit more exact if you want to. I'm happy for you to do that. But generally, that's what the graph should look like. So now I come back to my inequality questions. I ask the question, dashed or solid? So I look at the inequality symbol. Since there's no underscore here, the line should be dashed. So I'll go through and make it dashed. And generally, it's easier to make it dashed at the beginning than to go back and erase it, but I don't care what you do. So there's our dashedness. And now the next question, do I shade above or below? As you get more examples under your belt, you'll be able to do this easier. But I'll just pick a test point, 0, 0. 0 is greater than negative 2. That's true. So that tells me that I should shade where inside the parabola. Okay. And there we are. So again, every point inside there represents a solution to the system of inequalities. So now, of course, the next idea is to put these processes together, and thus we have a system of quadratic inequalities. Okay, so when we say system, we mean more than one. Right? System of equations, more than one equation. System of inequalities, more than one inequality. Okay, so now we're just doing 2 of these quadratic inequalities on the same graph, and now it's going to be where their areas intersect, or the areas overlapped. That'll be the solution set. So we've seen this before with linear things. This time we're going to do it with quadratic things. Okay, so quadratic inequalities. So this first graph, we actually know what that looks like. It's the one we just did. Right, so careful, the scaling on my graph is by 2s, so that's going to throw us off a little. Okay. And since this is greater than, strictly greater than, again, it means that I should have this dashed, and it means I should shade inside of the parabola. And again, don't start shading yet. I would tell you, just draw some arrows, remind yourself you're shading inside, and just do the final shading when you're ready, when you're all done, when you've graphed both inequalities. Okay. Now this is a little bit different than the other inequality that we just graphed. And so I'm going to recommend just strictly going with an XY table approach. Unless you're using a graphing calculator, obviously graphing calculator won't have any problems with it. But for the second one, I'm going to go with an XY approach. And I'm just going to try to get some X values and get this close enough. Okay. So if I pick an X value of 2, let's see, that gives us 4 here, but it's negative 4. Negative 4. This will be negative 6. So it's negative 10 plus 4 is negative 6. So 2, negative 6. So there's 1 point. I know that this is a quadratic, so I know it's going to be a parabola. I know that this is negative, so it's going to be opening the other direction. Right? The Quadratic has to be opening down. Okay, so that's a little bit of knowledge. Let's plug in 0. If I plug in 0, I get 4. That's an easy one. So here's 0, 4. All right, let's try something, because the graph gives me a little bit of a hint that there should be something going on over here. So let's try -4 and see what we get. So -4 will be -16, right? Because -4 times -4 is positive 16, but then there's a negative. So -16 plus 12, so that is -4 here, plus 4 should be 0. -4, 0, so 2, 4. I still don't quite have enough, right? Because I'm guessing that it's going to come up like this and then down, but I don't quite know how high it goes up before it starts coming down. And so we really need to find where that vertex is, and or use the graphing calculator to help us find this point. But for right now, I'll just kind of estimate a graph. Let me try that again. That looks like that. And if you did that on a quiz or a test, I would give you credit. I'm looking for the general representation. If I wanted exacts, you could just show me the calculator, and that would give me the exact. Okay, but roughly that's where that graph should be. And then the question is, where do I shade for the green graph? Do I shade outside of the parabola or inside of it? And so I see that I'm less than, so less than or equal to, which means the line should be solid. And in this case, I will shade inside the parabola. And if you don't believe that, you can always pick a test point that you're confident is inside here. So 0, 0 should be fine. And we get 0 is less than or equal to 4. So it is good. So now we're shading underneath this parabola, but the solution set is the areas that intersect. Okay, so I need to be under the green, and I need to be inside the green and inside the blue. Okay, inside the green and inside the blue. And so the area that becomes the solution set is just this little guy in here. And that space is the solution set to this system of inequalities. And so you can see we're going to get some interesting shapes now that are a little bit different than what we had with linear functions. Okay? All right, so here's a problem. Again, this is a system of quadratic inequalities. Why don't you try this at home, in the classroom. See if you can do it by hand. Start with a by hand approach, and then see if you can verify it using your graphing calculator. The TI Inspires will graph inequalities for you, and so will the 83s, 84s. It's just a little bit of a different process there. So make sure you know how your graphing calculator works to be able to graph inequalities. Right, so please pause the video now and work on this problem. Okay, so I'm just going to present how to do this using the graphing calculator, and specifically the TI Inspire. All right, so here I'm in the graphing screen, and I'm going to backspace through the equal sign, and it immediately gives me my inequalities. Okay, so I'm going to go with less than, because I think this graph is less than, negative x squared plus 3. And there we go. Now, I have had a few students in my first period class who were getting errors there, and the easiest solution I had for them was to just create a new document, and they were able to then do this. Okay. So again, the process was I went down like I was going to enter the equation. Instead, I just backspace or deleted through the equal sign. It gives me the inequalities options. Otherwise, you can actually type in an inequality option here. I believe the next one is y is greater than or equal to 2x squared plus 3x minus 2, 2x squared plus 3x minus 2. And there's the graph here. So again, the solution set is the intersection between the two shaded regions. Okay. So if you're doing this on a quiz or a test, you should graph both quadratics, both parabolas. You should graph both of these pieces. But then the only place I really want you to shade is just this area where they overlap or intersect. Okay? So this will conclude the introductory part to Section 4.9. Thanks for your attention. We'll see you next time. Here. We'll leave you with a problem for the closing credits. All right, so think on this problem, and we'll talk about it next time. Great.